Good afternoon. Happy Friday, everyone. My name is Matteo Rebeschini. I'm a security specialist at Elastic. And we're here to talk about Elastic Security solution. How many of you are familiar with Elastic or the ELK stack or Elasticsearch? So a few of you. So Elastic is the company behind a very popular search technology called Elasticsearch that powers many of your search experiences every day, whether you know it or not. Every time you get a ride using Uber, the match between the driver and the passenger using geospatial search is done by Elasticsearch. When you search on Yelp for restaurants, or you look at Wikipedia or eBay, that's all powered by Elasticsearch. So that's how Elasticsearch started. It started as an application search technology that was released to the community as an open source product. And the community started using Elasticsearch for different use cases, starting with ingesting logs for observability. And that has quickly evolved to metrics and security. I joined Elastic a little bit over 5 years ago, and at the time we didn't have a security solution, so nothing out of the box designed for security. Yet I found out when I joined that our largest customers at the time were using Elastic for security. So what Elastic has decided to do in the last few years is to make it easier for our users to use Elastic for security by providing content like detection rules, by creating workflows for the analysts. And I'll share with you the context of what I'm talking about in a minute. So if you think about the modern security challenges, and again, this is more on the defensive side, right? If you work for an organization, you're a security professional, security analyst, your job is to protect the assets of the organization, whether you're thinking about employees, the workstations they use, the intellectual property, any system that is powering any activity that is mission critical or revenue generating must be protected. Any downtime has a cost. It doesn't matter if the downtime is caused by a bug or by a cyber attack, there is still a cost. And that's how cybersecurity is also involved in those type of conversations these days. So when Elasticsearch was released as an open source project, the community, again, started using Elasticsearch for different use cases, but again, it was just a REST API, scalable search technology. And if you know IT administrators and IT ops, they don't really like to write code and use the REST API. So other community members, they came about and say, okay, maybe I should create a user interface that will make it easier to search and visualize logs. And that's how Kibana was born. That's the name of the user interface. And others came about to create other components to make it easier to ingest data into Elasticsearch. And this is how Elastic has been looking for a while. So you have the capability to ingest and store any type of data. At the core, in Elasticsearch, is a JSON documents that are stored, they're analyzed at ingest, with the goal of making any subsequent search fast. And when I talk fast, I talk about millisecond response. What we have done with Elastic Security is really adding on the top of the basic functionality that you expect from the Elastic stack, fast and scalable, being able to create powerful analytics and visualizations, keeping the open aspect. All the source code of Elastic is still open. Even our detections and protections are open. And the support, adding capabilities that you would expect for a security use case. And the core security use case of Elastic Security is SIEM, Security Information Event Monitoring. The idea is ingesting all documents centrally and being able to search them. So you can visualize activity that goes on within the infrastructure. Since we released Elastic SIEM, we added additional capabilities, starting with endpoint security. So now with Elastic, in addition of the capability to visualize what's going on within your infrastructure, you can also add protection at the edge on the endpoint. With endpoint protection, EPP, and endpoint detection response capabilities in Elastic Agent. And more recently, we have released also cloud security capabilities that I'll talk in a minute. So this is Elastic today. Again, capability to ingest anything, search and analyze at scale, visualize, and on the top of that, you have all these security features that are very, very relevant to any use case in organizations. If you're still students, or if you just want to play with technology, we still have a free tier that applies to all these use cases. So if you have a home lab, you want to have a SAM, you want to add protection to your laptop, you can deploy Elastic. You don't need to interact with us. You just have to download the binaries and do it yourself. So this is a structure for the demo today. I was planning to do a live demo, but then when I found that the screen was so small, I'm like, you're not only going to be able to see the mouse, but I'm going to try to deliver the points that I would have made in a live demo. So these are common challenges in the security space. Again, think about the context of gaining visibility, what's going on within your infrastructure, your environment, within your distributed workforce, and adding protection as you observe. The core requirement of a SAM is to be able to capture all the machine data that is generated by all the different devices that you use. And for those of you that have some experience with SAMs, you know that it's typically challenging to be able to, first of all, afford to ingest all the data, but also to keep up with the constant volumes of data that go up. So the first thing we did when we started working on Elastic Security is let's make it easier to ingest data from the most common log source types that are top of mind for security professionals to gain visibility. So now we have hundreds of data integrations that you can simply use. Elastic is designed for search, so whenever you ingest any data into Elastic, the data is normalized, and additional metadata is generated to make any subsequent query fast. Any of these integrations does just that job. Compared to other vendors in the SAM space, we have a very high focus on what I like to refer to as emerging log source types. Especially during COVID, there has been an acceleration of moving to the cloud, moving to SaaS. And suddenly, once you start using those SaaS services, you still want to gain visibility. I want to see what my employees do when they use 1Password to access one secret. So 1Password actually was the #1 top requested log source type that we didn't support at the time at the beginning of COVID. That's right when organizations started to say, okay, you have to work from home. We need to find a way to manage secrets, but I want to see who is accessing what. Once you have all the data stored inside Elasticsearch, you still would like to keep it for as long as possible, right? Whenever you as a security analyst, you have any indication of compromise, you start a process called security investigation, where you try to find the initial vulnerability or what happened that allowed a bad actor to gain access, because you want to patch that hole. So you have a need to be able to go back in time and figured out what happened, and figured out what other systems got compromised. And one of the ways to do that is to keep data searchable for extended period of times. Many organizations, actually most organizations, commercially and non, they also have compliance requirements that require them to keep data around for like 1 year or more. And that is typically very expensive. And what different vendors and technology vendors have done is to introduce the concept of data tiering. So you use different type of compute and hardware at different stages of the data life cycle. So at Elastic, we have done something similar, but a new feature that has been a game changer for security is the introduction of a feature called searchable snapshots. So the idea is that as data ages, move it off your deployment, store it in S3 or in an object store, and you want to still be able to search it without having to rehydrate it or restore the data into the deployment first. And that's exactly what searchable snapshots allows you to do. And the performance I'm talking about is minutes. I'm not talking about wait 24 hours before you have access to the data, or wait several hours before you get search results. So all of this is automated by Elastic. Depending on the type of data that you ingest, you can choose how you want to manage it. I want to keep it a couple of days searchable in the cluster, then move it to frozen. Maybe I want to delete it. All of that can be automated. So this is the first challenge that we covered, right? And we saw how Elastic can allow you to easily capture data with many out-of-the-box data integrations, and also manage the life cycles to keep control over also your cost that you pay, because your deployment size can stay the same. You can ingest more data, just move data to frozen faster. The second challenge, you can only have so many eyes on a dashboard, right? You want to leverage automation as much as possible. If your students are looking to start a career in cybersecurity, that's a very smart choice, because there's very high need for professionals in this space. That said, you want to leverage automation as much as possible. When we talk about security and automation in the context of security information event management, there are different types of automations that are used. The first type of automation is called detection rules. This is looking for common techniques that we know adversaries use when they do attacks, and MITRE as being instrumental in developing what they called MITRE ATT&CK. They basically cataloged all the techniques that adversaries commonly use. And some vendors, including Elastic now, when they release their content, they map their detection rules to MITRE ATT&CK TTPs. So when you just get this content out of the box, you enable these detection rules, and whenever any of these activities is seen within your environment, you get an alert. It doesn't necessarily mean that something bad is going on, but it's certainly an indicator that you should look into it. And that's really the job of tier 1 security analysts. They look at these detection alerts, they make a determination. Is this a true positive, a false positive? Should we be worried about this? Or was this just an administrator doing something as part of their job? So this is all very helpful, but it's not everything. The majority of the customers I work with, when they're asked, what are the use cases that are top of mind? What are you concerned the most about? They tell me, compromised accounts, malicious insiders. And the way to detect compromised accounts, again, this is from the logs, is an authenticated user with the right of access, but someone is impersonating that user. How can you figure out if there is the right person that is attached, that should use that account behind the keyboard, or if an adversary is doing that? This is where machine learning and user entity behavior analytics comes into play. Any data that you store inside Elasticsearch can be used to train machine learning job models. So the idea is that you use the machine to observe what's normal for a user, for an entity like a machine, build a model, so there is a lot of mathematical complexity behind it, right? But we hide all of that, and let you know whenever there is a deviation from what was seen as normal. If Matteo, I work in accounting, I work 8 to 5 every day from the Minneapolis office. Suddenly, I log in from Russia at 3 a.m. in the middle of the night, and I try to access a Google Drive folder that I never accessed before. Maybe it's not Matteo behind the keyboard, right? But try to keep track of that when you have thousands and thousands of employees that you don't know directly, right? Machine learning is really helpful for this. All the alerts in Elastic, whether they're generated through traditional detection alerts, whether there is some malware detected on an endpoint, whether it's an anomaly detected by machine learning, they're displayed to the analyst using the same alerts view. So this is basically the to-do list for the tier 1 analyst. When they show up at work in the morning, say, okay, these are the alerts that triggered. I need to start investigating them. But what should I look at first? So one of the key aspects is being able to prioritize these alerts in a way that makes sense to minimize the risk for your organization. So what we have added to Elastic Security is entity analytics. So what this means is that we start looking at users and hosts and attach a risk score to them based on the activity we see happening. If a user, Matteo, has many detection alerts, like maybe some malware detections, some unusual behavior, all of a sudden attached to my account, then there should be a very high risk tied to me. Likely my account was compromised. So any detection alert that includes my username should have a higher risk score. Or maybe you have some critical assets where you store your secrets, your intellectual property, the secret Coca-Cola recipe. You want to keep an eye on those. So whenever there is any alert that includes that specific machines, you want to bubble up and increase the priority based on risk. All of this can also be used in Entity Analytics dashboard to kind of show you what are the top risky users or assets. Right, this is part of the automation. Let the machine do the work. Again, a lot of content that you get out of the box. All the detection rules that we have, most of those are mapped to these MITRE ATT&CK TTPs, again, techniques that adversaries commonly use. Streamline detection and response. So we put a lot of thought into the work of an analyst, which, by the way, can be quite tedious, right? The analyst is the one that is looking at those alerts and is doing investigations every day. And there is a lot of turnover in that role, right? It's not really necessarily an easy job to do, especially because in many occasions, you feel like you're never winning, right? You're always trying to play catch up. And a lot of the new analysts that companies hire, they're coming out of boot camps or cybersecurity classes, because it's really hard to hire professionals that have experience in that field, because there is a lot of demand. Again, there is more demand than availability of resources. So what we have been doing at Elastic is trying to think about investigation workflows that are intuitive for the analysts, where you don't have to learn a complex data processing language to do a query. You can just do drag and drop to build your investigation. We use a graphical representation of the action described by log messages, so you don't have to open up a log message and look at all the different fields to understand what is this telling me. We make it very, very simple. Again, probably you're not able to see the details, but this is a brand new interface for those of you that know Elk a little bit, that really replaces the need for you to use Discover and is specifically designed for the analysts. As an analyst, as you use Timeline to go through all your log sources and the time dimension, searching through data, you can ping interesting events that are tied to a possible incident. You can create a case. We have case management, and all of that is part of the product as well. So we just saw our fast, intuitive workflows for security analysts, that thanks to Timeline, that we added to Elastic Security. So the last 2 bullets here, stop attacks at the source. So still today, the majority of the attacks starts at the edge. What do I mean? The endpoints that your employees are using, the servers that you're using to power your fleet, powering your applications. And that's what has made really popular the vendors that do endpoint security, EDR, endpoint protection. It's not just malware, but it's also gaining visibility on the endpoint to see what happens on the endpoint. If you look at MITRE ATT&CK, and if you look at those TTPs, those techniques that adversaries commonly use, if you look at the type of logs and visibility that you need to have in order to see those, you need to be able to see what processes are being run, what files are being created, what registry keys are being changed in the registry. And that type of telemetry are not logs that are natively generated by an operating system. So if you look at Windows event logs on Windows, you don't see when a file is changed. You don't see when a registry is changed, unless you add sysmon or there are other ways to do it. But natively, you don't see that. So what we have done at Elastic, in a true XDR fashion, this new acronym that basically describes endpoint security and SAM together, we added endpoint security capabilities to the same agent that Elastic uses to observe, to ingest logs. You can enable an integration called Elastic Defend that will turn that same agent running on an endpoint, and by endpoint I mean Windows, Linux, or Mac. And that agent will add malware protection, ransomware protection. It will block memory threats. And at the same time, while you are on the endpoint, you can gain visibility from the kernel, and you can configure that same agent to stream, to act as a sensor. Tap into the kernel. Every time there is a change to a file or a process, generate a log message, and send it back to Elastic, so you can visualize that. And all, again, going back to the alerts view for the analysts, whether you're looking at a MITRE attack detection or a machine learning anomaly or something that happens at the endpoint, it's all displayed in the same view. So same platform. The analyst doesn't have to learn multiple systems to do their job. For those of you that are into malware, and I think many of the attendees here may like to go deep with malware and learning how malware works. We created one of my team members created a website called Oh My Malware, where we publish a series of episodes, and each of them is related to a different type of malware. You can have access to Elastic. You can see what the malware did, learn about the malware. So, ohmymalware.com for that. Right, so we saw how Elastic provides full XDR capability in one platform, one agent, to both observe and protect all your endpoints. We also have, as part of EDR, response capabilities on the endpoint. As an analyst, when you detect that an endpoint is compromised, you can isolate the endpoint, meaning that there is no lateral movement. You can retrieve files, and you can do other actions on the endpoint. So 3 minutes left for the last bullet. Take security to new heights. Pretty much any organization I work with, they're moving workloads to the cloud. And that has become of attention also for the bad guys, right? So it's very easy to stand up workloads on the cloud. Gartner predicts that by 2025, 95% of the new workloads will be cloud native. And guess what? Through 2025 also, pretty much every single cloud breach is not going to be caused by malware, but by misconfigurations. Right? Cloud is new to many. Even if you think you're an expert in AWS, maybe your employer will tell you, oh, now we want to implement a multi-cloud strategy. I want you to start using Azure. And guess what? While they may look similar, when you start looking at the security policy and all of that, there are changes that you have to learn. That's part of it. So we started adding cloud security capabilities, starting with cloud security posture management, CSPM. That also includes support for Kubernetes. So the idea here is to use CIS benchmarks. Think of them as best practices for hardening the configurations of system, whether you're looking at a Kubernetes cluster or cloud native. And you configure Elastic, in this case, to keep checking on the configurations of your system. And it will let you know if you have any opportunities to improve the posture. It will also tell you what you have to change in the configuration to do that. The other aspect of these is gaining visibility within containers. Kubernetes and containers are becoming really popular as a way to deploy production workloads. And one of the reasons for that...
Attention all guests for the Midwest Gaming Classics. Will the owner of a U-Haul trailer with an Arizona license plate, A as in Apple, E as in Echo, 3119, again, U-Haul Arizona plates, AE 3119. Please come out to the dock and move your vehicle immediately. You're blocking traffic.
I guess that's the only way to find someone. And I was saying Kubernetes is becoming really popular because if you start designing applications to run on Kubernetes, Kubernetes makes it really easy to move them from on-prem to a cloud provider and from a cloud provider to another. One of the challenges with Kubernetes is to gain visibility to what's going on within a container. And also, how can you add the same level of protection that you can have on an endpoint with EDR within a container? So using a technology called eBPF that many of you probably have heard of, Elastic allows to tap into the kernel, You can deploy Elastic Agent within Kubernetes. We don't have to instrument your applications. And gain visibility within the container itself. The visibility can look like this. You can see as if you're standing behind a keyboard of someone typing a command and seeing the output. You can get all this telemetry. We call it console view. And we also added an initial release with drift protection that will allow you to see if a container starts acting differently than what was seen in the past. So more to come on this. And again, one platform, and our vision in general with Elastic Security is to provide the same level of visibility and protection across the entire attack surface, from traditional endpoint, Windows, Linux, or Mac, cloud native, and Kubernetes. So this is what we covered today. Was this helpful? Do you have any questions about Elastic in general? Yeah. No, you cannot. So there are two components in Elastic. One is the platform, right? That you have. It's usually a cluster of nodes. It's based on Java, Lucene, the Lucene open source library, and then you have Elastic Agent. Elastic Agent can be deployed on Windows, Linux, or Mac, or can be deployed within Kubernetes. But you cannot install an agent inside a device like an appliance. In the case of routers, firewalls, network appliances, usually you use syslog over the network as a way to get logs out of those devices, and you will configure Elastic Agent somewhere to listen on a specific port for those messages. Okay, we're out of time. Thank you everyone for joining and for sticking around on a Friday afternoon.